Today's video is the Finding Zeros worksheet. So let's start with number 1. It says, which of the following is a zero of the function x squared times x minus 4 times x plus 1? So what you want to do is, in order to solve each of these pieces get set equal to 0. So we have x squared equals 0, x minus 4 equals 0, and x plus 1 equals 0. So when we're trying to find zeros, we just set the functions equal to 0. So we could have a 0 that equals 0, positive 4, or negative 1. And we're looking for which one of the following answer choices could be a 0, and the only one that pops up is option D. So remember, anytime you're trying to find a 0, you set the piece equal to 0. All right, number 2, in the standard xy coordinate plane, we have a polynomial that crosses the x-axis at all of these times. So it's crossing at -3, -2, 4, 5, and 7. We're looking for which one is a factor. So in order to actually calculate this correctly, sorry, my walkie-talkie is going off. Let me turn it off real quick. Okay, so in order to correctly figure out which one of these values is a factor, all we have to do is work backwards, okay? So the -3, this basically starts as x equals -3. To work backwards and make this equal 0, you would add 3. So this now becomes x plus 3. So all of these answer choices have parentheses around them. So we're looking for basically the opposite of all of these functions. So x equals positive 3. Well, in order to get these correct answers, we're looking for which one is actually going to give us which one is a 0 except. So x equals positive 3. I don't see that as an answer choice. Over here with the -2, this would be x plus 2. Well, x plus 2 is on here, so we're good. 4, that would end up being x minus 4. That one's on here. 5 would be x minus 5, which is an answer choice. And 7 would be x minus 7, which is also an answer choice. So A is the one that is not a 0. So all you're doing here is kind of working backwards and putting the coordinates backwards into parentheses. Number 3, how many imaginary roots does x squared plus 1 have? So what I would do is just kind of solve it. So I would subtract. So we're looking for how many roots. That's the same thing as zeros. So this would be 0 equals x squared plus 1. So -1 equals x squared. When I square root a negative, I get I, but it's also positive or negative. Remember, square rooting can give you a positive value as well as a negative value. So that is actually 2 potential values for roots. Also, this is a squared function. So remember, it's quadrilateral, not quadrilateral, I'm sorry, a parabola with a squared. You can have up to 2. So in this case, there are 2 imaginary roots. Number 4, the graph has crossed the x-axis, which, if the graph does not cross the x-axis at any other point, which of the following could be a function of this quadratic? So here's the thing about this. This is a negative number. This is a negative number, and this is actually a positive number, okay? So what we're doing here is I'm just going to look at my pieces. I'm looking for which one of these could be 0. So if I do x plus 3 equals 0, I could get a -3. X plus 4 equals 0, I would get also a -4, so that would take care of the first and second negative number. And on this one, I would get x minus 1 equals 0. And if I add 1 over, that would give me one positive number, which would be answer A. So what I would recommend is just setting each piece equal to 0 and then kind of analyzing where those fall in the graph. So we needed 2 negatives and 1 positive. And when we solved for option A, those are the answers that we got. Number 5, in the xy coordinate plane, which of the following functions would have a graph that crosses or touches the x-axis at only one point? What I would recommend is just graphing. So I'm going to go in here and I'm just going to graph. So let me move this down just a little bit. So the first one is x squared plus 5. Oh, sorry, let me go in here. Okay, well that clearly does not touch the x-axis, so I'm going to, it has to graph the whole cycle. So I'm going to go back in here. I'm going to delete the first, delete this one. So x plus 5, when we graphed it, it did not touch at all, so A is not the right answer. So now I'm going to graph the second one. So this would be minus 6. We're looking for which one touches only one time at one point. This crosses at 2 points. So B is out. Next we have x squared minus 8x plus 16. We'll graph that one as well. When we graph it, notice how it only touches at one location here. So the correct answer is answer C. So on a problem like this, you actually don't even need to graph it or solve it. I would just recommend graphing it, because when you graph it, it's a little bit easier. Then you don't even have to spend the time to factor. Number 6, which of the following functions has the same roots as 3x squared minus 3x minus 27? Hopefully you notice the GCF, 3, 3, and 3. If I pull a 3 out of this function, this would become x squared minus x minus 9. And looking at my answer choices, this piece of my function matches option E. So all we did here was pull out a GCF. So all you have to do is pull out a GCF, and that will give you option E. You don't have to waste your time doing factor by grouping. This problem would take entirely too long if you wanted to do that. So what I would recommend is going ahead and just looking for GCFs to be able to simplify. Number 7, if A, B, and C are non-zero real numbers, what is the least number of times that a function could cross the x-axis? Well, whenever you have a function and it's telling you that it's squared, so you know it's a parabola, you could have a function that has a root that is imaginary. So technically, it doesn't have to cross the x-axis at all. Depending on the actual function itself, it could be imaginary, which is option A. On number 8, which of the following represents the y-intercept located at 0, 2? So 0, 2, that means that this location is 2. And it says for whose x-intercept is located at negative 4, so that means that this location is negative 4. We're looking for what values of x must be greater than 0. So we're looking for the values of y, basically f of x. So remember when it says f of x, that is the same thing as y. So we are actually looking for y values that are greater than 0. Well, y values that are greater than 0 all start after it touches at negative 4. Not at negative 4. At negative 4, it equals 0. We're looking for greater than 0. So when our x values are greater than negative 4, the greater than negative 4 would be this direction. All of those values are positive, so it has to be greater than negative 4 for my x values for those y values to be greater than 0 or positive, which is answer choice D. Number 9, if one factor of a polynomial function is x minus k, what could be a 0 of the function? Remember, if it's a factor, it's going to look like this in parentheses, and if it's a 0 of the function, it's actually going to equal 0. So x would equal k, leaving you with answer E. So all we're doing here is we're taking our value and setting it equal to 0, and then solving for x. Number 10, let function f of x be defined as negative x squared plus c. For a positive value of c, if the function crosses the x-axis at negative 3 and positive 3, then which of the following must be true about x is less than negative 3? Okay, that's a lot. So what I would recommend first is you plotting this function. So I'm going to draw an xy plane. Has a negative, which means that the function and its squared is actually going to be flipped like this. So it has a vertical reflection in the problem, which we talked about in function transformations. It is crossing the x-axis at negative 3 and 3, which means this point is negative 3, and this point is positive 3. Which of the following is true for f of x, so our y values, when x is less than negative 3? Well, for the values that are less than negative 3, we are looking for values that are located here. Negative 3, that would be down below. Okay? So let's analyze our answer choices. Y has the same possible values for x of negative 3. Well, since it's a parabola, they're equal on both sides. So that is actually true. So sketching a graph would allow you to see that. Okay. Next, f of x, or y, is less than 0. That is definitely true. These numbers on the y-axis are negative. So 2 is true. F of x would equal c. Well, we know our c value is up here and it's positive. These values will always be negative. So this is in fact not true. So the correct answer is D, option 1 and 2 only. All right, on to the back. Number 11. Given the function of the graph f of x and g of x, what values of x is g of x's function greater than f of x's function? Okay, so we've got some coordinates here. So I'm just going to kind of mark on the picture so we know what functions to look at. So g of x's function is here. And we're looking for when g of x is greater than f of x. So f of x function is located here. So we're looking for the values of y in g of x is greater than f of x. And that actually occurs right here, because the g of x function is above the yellow, okay, the f of x function. So this actually happens at negative 1 to 4 for my x values, but it's non-inclusive. So the answer is B. It's between this negative 1 and this positive 4 that the change happens where g of x is actually greater than f of x. 12. For fixed real values a, b, and c, is the solution to this equation is negative 5/2. For what of these values would have the expression as a factor? So this number here, negative 5/2, that is a solution, which is just a 0. So basically, x is going to equal negative 5/2. We're trying to put it back into its parenthesis form. Okay, we're trying to put it in its parenthesis form equaling 0. So basically, I'm going to just add over here a plus 0 to kind of have this make a little bit more sense. We're trying to get this by itself, so we're trying to move all this stuff back over here. So we would multiply by 2, so we would have 2x equals negative 5 plus 0. Then I would add 5, so I would get 2x plus 5 equals 0, which is what we want it to be. So looking at our equation, option B is the only one that matches that factor. You're basically unsimplifying the factor. Now let's say you didn't think to do it this way. You could always solve each one of these and set each one of these equal to 0. If you set each one equal to 0, you're looking for which one is going to match negative 5/2. So 2 different ways to do this problem, just whatever you're comfortable with. All right, which of the following points is on the graph of the function? What I would do is solve each piece. So x equals negative 5 would say I wrote that completely wrong. This should read x minus 5 equals 0, so x equals positive 5. So that is answer choice B. I can continue this, so like right here, this is x plus 3 equals 0, so that is x minus 3, or x equals negative 3. That's not an answer choice. This one has it in the wrong spot. And then so on, this would be x equals positive 1, not an answer choice. And this one would be x equals negative 10. Again, not an answer choice. So the correct answer here is B. All you have to do whenever it says solution or what point is on the function, all you have to do is set the factor equal to 0. All right, number 14, let A, B, and C represent any 3 real numbers where A is less than 0. Okay. If a quadratic function, and then we have a squared bx plus c, that's just letting you know it's a parabola, has an x-intercept of 3 and 9, then what has to be true of f of 4? So what I would do is I would just kind of graph this. Okay, I would graph it, and it's telling you here that your A value is less than 0, which means that this value is negative. If the value is negative, it flips the function like this. Remember, if it says A is less than 0, that means that it is a negative number. The negative flips the parabola over. It's a vertical reflection. So that means that this location is 3, and this location is the 9. Those are the zeros. We're looking for f of 4. 4 would be like right here. Well, when this is 4, the y value would be somewhere here. We're looking for what is true. Well, this value we know is a positive, so the correct answer is B. The value of f of 4 is positive. Because if it's negative, the function flips. Negative number flips the function. F of 4 would be the x value is 4, so the y outcome is some positive number. And we see that when we graph it. So you have to be able to sketch the graph to kind of see what the value of f of 4 would be. All right, number 15. How many real solutions does 2x cubed equal 9 have? So what I would do is I would just graph it. So 2x cubed minus 9 equals 0. So then I can graph. So whenever you're trying to graph, I would set it equal to 0 first. Then you can properly graph. So I'm going to go ahead and move that up. And I'm going to do 2x to the third minus 9. And when you graph, you will be able to see how many real solutions it has. Notice how it crosses the x-axis at one point. So this has one real solution. Now, let's say you didn't know that, and you were like, okay, I would solve for y, and then I would hit graph. Or you could also just solve the equation. So I would divide by 9, so this would be x cubed equals 9 over 2. Okay, and when I do 9 over 2, I would just cube root it. So when I cube root, I would get x equals the cube root of 9/2. And then I would just graph it. And then it would tell me that's obviously one answer, so it's B. I would recommend graphing. I think it's just a little bit easier. All right, let's try the next one. Number 16. Oh, there it goes. The complete function of the graph is shown. How many real solutions does f of x equals 0 have? Well, notice how it crosses at one point, so it has one real solution. One real solution. Real means that it actually crosses over the x-axis, so it has one real solution. All right, number 17. If graphed in the xy coordinate plane, which of the following functions would have a graph that does not intersect the x-axis at any point? Does not intersect the x-axis. I would just graph, honestly. You could do function transformations and kind of think about it that way, but graphing is just a lot faster. You can type it in your calculator and you don't even have to think of it. So I'm going to do negative x squared plus 10. Graph. I see that it obviously crosses the x-axis, so we know that A is out. Negative x squared minus 15. And when I graph, I notice that it's not crossing at all, so what I'm going to do is adjust my window. I'm going to just change the x to negative 20. We'll make this positive 20. We'll just increase everything by 20, so you can always do this, and now it's made the graph smaller. So now you can clearly see that it's down here at negative 15, which means that it's not actually crossing the x-axis at all. So the correct answer is B. Now you could also use function transformations. Okay, so to use function transformations, the parent function is x squared. So this is the parent function. Okay, parent function. Now, you can also adjust the parent function. So looking at this problem, we want to flip it over the axis. So it's going to flip it this direction, and then it's going to go down 15. So it's going to kind of be like this. This is the final graph, and that is definitely not touching the x-axis. So you could use function transformations, or you could graph, depending on how you would like to do these problems. So it's completely up to you how you do them, whatever is easier, whatever you're more comfortable with. Number 18, which of the following expressions represents a polynomial with exactly one root? Again, you can graph this or you can factor it. I'm just going to show it the graphing method. I changed my window back. So I'm going to go back in here, clear it out. I got x squared minus 3. So all that does is it takes an x squared function and shifts it down 3. Again, it's crossing twice, so that's not my answer. I'm going to go down here to -1. That is the same idea. It shifts the function down 1, so it still has 2 real roots. Next, the function is +1, and that just shifts the function up 1, so this has no real roots. So now we're going to get into the more complicated problems of x squared plus 2x plus 1. Graphing this function, notice how it crosses at exactly 1 point of -1. So answer D is your correct answer. Now, if you were to factor this, eventually you would factor it and it would come down to x plus 1, x plus 1. Notice how these numbers are identical, so that lets you know that you have one real distinct root. So again, you can do it by factoring or you can do it by graphing. Number 19, which of the following is a factor of x squared minus x minus 12? I'm just going to look for two numbers that multiply to equal -12 and those same two numbers that add to equal -1. The numbers that I'm using are going to be a 4 and a 3. And since I want them to add to a -1, that would mean my 4 is negative. So this will break down into x minus 4 and x plus 3 equaling 0. And that factor is located right here, which is option D. So this one, x minus 4, that is in fact the factor of our equation. And the last one, f of a equals 3a squared minus a cubed. Then what is the following value of f of -2? So this becomes 3 times -2 squared minus -2 cubed. Well, -2 squared is positive 4. And -2 cubed is -8. So this becomes 12 plus 8, which is 20. Remember, anytime you're doing factors, you can always graph. And this is just a function that you're evaluating, and you just plug it in.